Hi everyone, my name is Jordan Steffen, and my protein for the protein project is troponin C. So this is just a 3D structure of troponin C. It's a globular protein, and that has 162 amino acids. Its molecular weight is 18.4 kilodaltons. It's made of 2 globular domains, and it contains alpha helical structures that are connected with beta loops. At the C terminal, it contains 2 high affinity calcium binding sites, which are always occupied by calcium or magnesium, and it's a stabilizing unit, and it's an open conformation that remains anchored to the rest of the troponin complex. And it also contains an end domain, which is it has a single low affinity site that is largely unoccupied at the resting calcium concentrations. So biochemical function of troponin C. So it binds to calcium to allow conformational change to occur, which removes troponin I from the thin filament actin muscle fibers, which this change allows the troponin complex overall to pull turbomyosin off of actin completely, which initiates muscle contraction in the coupling phase. So this allows motor proteins like myosin to bind to that actin to continue that muscle contraction overall. So isoproteins are located in blood rich and fast-twitch skeletal muscle fibers, as well as cardiac muscle fibers. So disorders that involve elevated troponin C levels include heart failure, hypertrophic cardiomyopathy, acute myocardial infarction, myocarditis, acute pulmonary embolism, and stage renal diseases. So skeletal muscle disorders also include myotonic dystrophies and Amish single line myopathy. Those are more so associated with the other portions of the troponin complex, like troponin I and troponin T, but if the calcium doesn't bind, there's no contraction that can be initiated. So this is why these disorders occur overall. So why does troponin C affect cardiac patients? Well, people who have cardiomyopathy, it makes it much more difficult for their hearts to pump blood throughout the body. So it can lead to a heart attack or heart failure. These mutations can cause cardiac enlargement or swelling of the heart and hypertrophy, reduced contractility. We need the heart to be coordinated so it pumps blood throughout the body properly, and overall sensitivity to calcium. So when complications arise in the heart, troponin is released into the bloodstream, and the longer that troponin stays in the bloodstream and the higher the levels are, the worse the heart is injured overall. So why am I interested in troponin C? I'm an exercise science major, so I deal a lot with muscle contraction and relaxation. And I'm also a phlebotomist, and we draw lots of troponins on cardiac patients in the hospital. We like those levels to be between 0 and 0.4 nanograms per milliliter. If they're not within those ranges, we know that there's something going on in the heart. So here are my references. I hope you guys enjoyed, and if you have any questions, let me know. Thank you.